Alright, this is Algebra 2, Lesson 32, and this lesson covers quotient theorem for square roots, congruency, and congruent triangles. Alright, so first we're going to talk about the quotient theorem for square roots. And we remember that the square root of 3 times 2 is going to be equal to the square root of 3 times the square root of 2. Easy, so we can just separate those out there as long as we have a square root sign on both of those. We also know that the square root of 3 over 2 is equal to the square root of 3 divided by the square root of 2. Okay, so we can just separate those out into two separate square roots. Alright, so in our problem 32.1, we've got the square root of 3 over 7. So we're just going to first separate that out, have the square root of 3 over the square root of 7. Now we're going to multiply the top and the bottom by something. So that's not going to change the value of the fraction if we multiply the top and the bottom by the same thing. I'm going to multiply it by the square root of 7. Okay? If I multiply it times the square root of 7, the square root of 7 times the square root of 7 just equals plain old 7. So we rationalize the denominator. We don't have a square root in the denominator anymore. Then 3 times 7 is 21. So we've got the square root of 21 over 7, and that would be the answer. Alright, let's do another example. This one is 32.2, and it says the square root of 2 over 5 plus the square root of 5 over 2. So first thing we're going to do is we're going to separate these out. And then we've got square root of 5 over the square root of 2. And what we're trying to do first is rationalize this denominator. So we're going to multiply this times the square root of 5. And whatever we do the top, we got to do the bottom. And same thing here, times the square root of 2, and do that up here, times the square root of 2. And we're going to end up with, these are going to cancel. We're just going to have 5 on the bottom for that one. And these cancel each other out. That would end up being the square root of 4, and the square root of 4 is 2. So we got 2 on the bottom. Okay. Right here we're going to say 2 times 5 is 10. And right here we're going to say 2 times 5 is 10. Okay, now we're adding. We still can't add because we need our denominators to be the same. So what we're going to do to fix that is we're going to multiply this one times 2 over 2. Right? We're going to multiply this one times 5 over 5. 5 times 2 is 10. And up here, we would have 2 times the square root of 10. Okay, here we said 2 times 5 is 10. And up here, we're going to say 5 times the square root of 10. Okay, so then we can actually add these because our denominators are the same and our bases inside our square roots are the same. So we can say 2 times the square root of 10 plus 5 times the square root of 10. So basically these are like terms, and we're going to end up with 7 times the square root of 10 over 10. So that's the answer to that one. Alright, let me do another one. 32.3. This one has 3 times the square root of 3 over 7 minus 5 times the square root of 7 over 3. Okay, so on these, what we're going to do when we separate these out is our whole number is going to stay attached to the top of that fraction. So it's going to be 3 times the square root of 3 over the square root of 7. Okay, minus 5 times the square root of 7. So I'm just attaching this whole number to this top right here, not the numerator of the fraction, not the denominator. And I'm left with square root of 3 right there. Alright, so now I have to rationalize this and get rid of these. So I'm going to multiply this times the square root of 7, and this times the square root of 7. Okay, and then I'm going to multiply this one times the square root of 3, and this one times the square root of 3. Whatever I do the bottom, I have to do the top as well. When I multiply these, I get the square root of 49, which is 7. So I got 7 on the bottom. Whoops, not 9. 7. Actually, I'm going to write it over on the side. You guys can see it better. Alright, so this one, I'm going to end up with 7 on the bottom. And then square root of 7 times square root of 3 is square root of 21. So I'm going to have 3 times the square root of 21. So I can only multiply square root times the square root. I cannot multiply that times the whole number. Okay? Then I'm going to subtract. And then this fraction, this will be square root of 3 times 3 is 9. Square root of 9 is just plain old 3. And then 3 times 7 is 21. So I got 5 times the square root of 21. Okay, I still cannot subtract these because I got to get my denominators the same. So I'm going to multiply this one. My new denominator, my common denominator between those is going to be 21. I have 21 on the bottom of both of these. So to get that, I'm going to have to multiply this one times 3 over 3, right? So 3 times 3 is 9 times the square root of 21. And look, I only multiplied right here. I'm multiplying 3 times 7 to get 21, and then I'm multiplying 3 times 3. I'm not multiplying 3 times 21. I can't multiply inside this radical box right here. I can only multiply radicals times radicals and whole numbers times whole numbers. So 3 times 3 is 9, okay? And then right here I have to multiply this whole side to get 7 times 7 to get my 21. So 3 times 7 is 21. There's my new 21 right there. And now I can only multiply my 7 times my 5. I cannot multiply it times 21. So 7 times 5 is 35 times the square root of 21. Just think of the square root of 21 as being like x. I wouldn't do anything with the x. I would just say 5x times 7 would be 35x. Alright, and that's subtracting. So now I can subtract, and I can say 9 take away 35, which would be negative 26 times square root of 21 over 21. And that's the answer to that one. I know these seem complicated. You can kind of do a shortcut to get rid of some of what you're doing. So let's say that we had square root of 3 over 7. We know that's going to be square root of 3 over square root of 7. And we know we're going to multiply times square root of 7 and times square root of 7. And we would get 21 over square root of 21 over 7. Now a shortcut for that would just be to say 3 times 7 is 21. That's what's going to go in the top. And then we're just going to put that over 7. So you just multiply your bottom times your top to get your new top. And you just get rid of the radical sign on the bottom. So that's kind of a shortcut that you can do. But I want to make sure that you understand how you're getting that. Okay. Next one is 32.4. And this is 2 times the square root of 2 over 7 minus 5 times the square root of 7 over 2. So let's use our shortcut on this one. So we're going to say 7 times 2 is 14. So we're going to have 2 times the square root of 14 over 7. And then we're going to have our 5 in our square root box. 2 times 7 is 14 over 2. Okay? So we just multiply to get what goes on the top inside the box. And then we leave our bottoms the same when we do that. Alright, now I got to find a common denominator, which would be 14. So our new bottoms are going to be 14 on both of these. And then I'm going to say 7 times 2 makes 14. So I'm going to have to multiply my top times 2 and my bottom times 2. Okay, 7 times 2, I get 14 right here. And then 2 times 2 is 4 times the square root of 14. And then on this one, I multiplied times 7 to get that. So times 7 times 7. 2 times 7 makes this 14 right here. And then I can't multiply it times what's inside the box, only what's outside. 7 times 5 is 35. So square root of 7. Okay, and this is subtract. Now I can subtract the whole thing because my denominators are the same. And, whoops, that should be square root of 14 right there. My denominators are the same, and these are like terms, square root of 14, square root of 14. So 4 minus 35 is going to be negative 31 times the square root of 14 over 14. So that's the answer to that one. Alright, let's see. The next part is congruency. In mathematics, only numbers are equal. So the equation 4 equals 2 plus 2, those can be considered as equal. for geometry, we don't say that geometric figures are equal. We call that congruent. So let's say that we had line AB, and let's say that it's 4 centimeters long. And then we've got line CD, and it's also 4 centimeters long. We're not going to say those lines are equal to each other. We call that congruent. And so congruent means geometrically equal. It means that the numbers that describe them are equal to each other, because 4 equals 4. All right, so those two lines would be considered congruent. Same thing with angles. So let's say that we have an angle and it's 37 degrees, and we have another angle and it's 37 degrees, and this is angle A and this is angle B. We can say that these two angles are congruent. So we could write them as angle A equals angle B. We could also write the measure of angle A equals the measure of angle B. Or you could write angle A is congruent. Okay, so that's what congruent looks like to angle B. Okay, so congruent is an equal sign with a little wiggly line on top. It means congruent. It just means geometric. It basically just means equal when we're talking about geometric figures. All right, so when we write that things are congruent, we want to be really careful that we put stuff in the right order. So let's say that we have two triangles, and this one's A, B, C. And then we have another triangle that goes up like this. Okay, and it is C, E, D. And then it tells us that this is a right angle and this is a right angle. So we want to be careful and make sure that when we write that these are congruent, we're going to name this angle ABC is congruent to, now we got to make sure we keep them in the right order. So this one by the hypotenuse right here is A, so that would be congruent with D. So we're going to go D, and then our right angle one comes next, E, and then C would have to come last, okay, because C came last on this one. So we got to make sure that these corresponding points, these corresponding angles line up. So A and D, B and E, and then C and C, and we got to make sure they're in the right order when we say that it's congruent, so that each angle that corresponds with each other comes in the right order. All right, that's pretty much most of that. Here's what a problem from that would look like. All right, so we've got a triangle right there, and we've got another triangle right here, and it says find X and P. All right, so we've got that and that are equal, and then it tells us that that and that are equal, which also tells us that this third one has to be equal because it's angle, angle, angle. So if two angles are equal, then that third angle has to be equal. All right, then it says 6x plus 2 on the bottom of this one, and we've got 12x minus 4 on the bottom of that one. This side is 4x plus 1, and then this side is 6, and then over here we have a 6, and then we have a P right there. Well, this 6 and this 6 tell us that these are congruent triangles, because if this corresponds to this and that one corresponds to that one, and both of these sides are exactly the same, that means that these are congruent triangles. All right, so that means P corresponds to 4x plus 1. This side right here is going to be equal to that side. That means that this is going to be equal to this. Now, we can't solve for P first. We're going to have to solve for X first. So we're going to solve for this bottom one first, this and this. So we're going to say 12x minus 4 is equal to 6x plus 2, because they are equal. Those lengths are equal. Now we're just going to try to solve for x. So if you get my x's together, those cancel, and I'll get 6x minus 4 equals 2, and then I'll just add 4, and I'm going to get 6x equals 6, and then I divide by 6, and x equals 1. Okay, so that's the beginning of that. X equals 1. All right, now we can figure out what this side is. If x equals 1, we've got 6 times 1 plus 2. 6 times 1 is 6, plus 2 is 7. So that means this side should equal 7. The bottom is 7. And let's see about this one. 12 times 1 minus 4 equals, well, 12 minus 4, that would be 8. Hang on, I did something wrong. 6, oh, plus 2, that equals 8. Yep. And this one is also going to equal 8. There we go. 12 times 1 minus 4 equals, 12 times 1 is 12, minus 4 equals 8. And 6 times 1 plus 2 equals, that'd be 6 plus 2 equals 8. Yep. So both of those come out the same. All right, now we got to try to solve for p. So right here, all we have to do is 4 times 1, because we know our x equals 1. We're just going to plug it into this equation, plus 1, and see how long that side is right there. So 4 times 1 is 4, plus 1 equals 5. So that's saying that this side right here is 5. So if this side is 5, then this side has to be 5. So that means p equals 5. So x equals 1 and p equals 5 on that one. All right, so pause the video and do the practice problems, and I'll come back and work them for you. Okay, so we're going to start with A. And A says the square root of 3/5 plus the square root of 5/3. Okay, so we're going to first try to rationalize this denominator. So we're going to say the square root of 3 over the square root of 5. And then we're going to be adding the square root of 5 over the square root of 3. To get rid of the square root, we're going to multiply this times another square root of 5 on the top and the bottom. And here we're going to multiply times the square root of 3 on top and bottom. And we're going to get, this will be square root of 25, which we know is 5. So right here we've got 5 on the bottom of that first one. And then we've got 3 times 5 is 15. Okay. And then plus this one, 3 times 3 is 9. So that'll be square root of 9. Square root of 9 is 3. So that's our new bottom there. And then 3 times 5 is 15. All right, we still cannot add. I'm going to copy that down to here. So square root of 15 over 5 plus square root of 15 over 3. Okay, I still cannot add these because I have to get my denominators the same. So the least common multiple of 3 and 5 is going to be 15. So I want my new bottoms to each be 15. So to get 15 here, I would have had to do times 3 and times 3. So that's going to be 3 times 5 is 15. 3 times the square root of 15. And then plus this one, I had to multiply times 5 on the top and the bottom. So we're going to have 5 times the square root of 15. Now I can add them because I have common denominator and my square root of 15 is like terms. So 3 plus 5 will be 8 times the square root of 15 over 15. All right, so that is A. Next one is B. Okay, and it's going to be 2 times the square root of 2 over 7 minus 3 times the square root of 7 over 2. And I'm going to use the shortcut on this one. I'm just going to say 7 times 2 is 14. So I'm going to say 2 times the square root of 14 over 7 minus 3. 2 times 7 is 14 times the square root of 14 over 2. Okay, see how I did that? I just multiplied 7 times 2 to get my inside my square root box here. And then I'm left with the 7. And then I said 2 times 7 is 14 to get that. And I'm left with the 2 on the bottom. If that's too difficult, then what you need to do is, if that is like throwing you for a loop, just do times square root of 7 times square root of 7 like we've been doing. Rationalize the denominator. Alright, so I still cannot subtract these because I got to get a common denominator. So the common denominator between 7 and 2 will be 14. So my new bottoms are going to be 14. For this one, I had to multiply times 2. So up here I got to multiply times 2. 2 times 7 is 14. 2 times 2 is 4. Now remember, I'm not multiplying this 2 times what's inside the box, just what's outside. All right, this one I have to multiply times 7. Okay, so 7 times 2 is 14. That's how I got my new bottom. 3 times 7 is 21. It's the square root of 14. Okay, so I didn't multiply inside the box. I multiplied the number that was outside. All right, and then this was subtraction. So now I can subtract because I have common denominator on the bottom. They're both 14, and these are like terms. 4 times square root of 14 minus 21 times square root of 14. 4 minus 21 would be negative 17. It's the square root of 14 over 14. And that is the answer to B. Okay. All right. Try another problem. Let's see. This is C. C is a picture. So we've got that. And then it goes up like that. Comes down like that. And then it goes across like that. Okay. And then it says that this line and this line are parallel. And then this one says 4x minus 1. And then this one says 4x plus 1. And then that's a 4. P 12x minus 7. And 4 right there. Okay, so let's see if we can find our pairs of matching sides. So this 4 and this 4, those are matching sides. And then we've got P and that one are matching sides. That means this one and this one are matching sides as well. Okay, so let's work on these first to solve for x. So I've got that equals that because these are congruent. It says the two triangles shown here are similar by angle, angle, angle. Two corresponding sides have a length of 4, so scale factor is 1. Those triangles are congruent because of all their angles are the same and one side's the same, so that means that they're congruent triangles. All right, so because 4 equals 4, and then all of our angles are equal because these two lines are parallel. All right, so what we need to do is figure out x by setting that one, and that one would be equal because this side is equal to that side. So we've got 4x plus 1 equals 12x minus 7. So now all I have to do is solve for x. So I'm going to say minus 4x. And we're going to get 1 equals 8x minus 7. And then I'm going to add 7. And I'm going to get 8 equals 8x. Then I'm going to divide by 8. And I'm going to get x equals 1. Okay, so that's the first part of the problem. X equals 1 solved. Okay, now I got to find P. To do that, I'm going to figure out how long this is, and then I'll know how much P is. Because 4x minus 1 would be equal to P. And we know that x is 1, so we're going to say 4 times 1 minus 1 equals P. 4 times 1 is 4, minus 1 equals P. 4 minus 1 is 3, so P is equal to 3. X equals 1, P equals 3. All right, so that is the answer to practice 32. This lesson and lesson 31 are the ones that we went over in class last Wednesday. So those are just for people that weren't in class. And the homework set was set 32. All right, that's it for that lesson.